Okay, we're continuing with lesson 4.2, and this video starts for page 102. We did page 101 at the end of the other video, and you'll see that in Schoology. It's dated January 5th. So, determining the rate of change and initial value. This slope-intercept form of the line. The M tells you the slope, the B is the intercept. They also refer to M as the rate of change. Now, you've heard that term before. They also refer to the B as the initial value, so where you actually begin your graph, the initial value. This form, slope-intercept, you'll use this form throughout the rest of your math classes, everything all through high school. If you go into college, they'll use this. It's not something you have to memorize, but because you use it so much, you will have it memorized. So again, the slope is the M, which is also called the rate of change. And your y-intercept is the B, which is sometimes referred to as the initial value. We're still on page 102, and they have example 1, and this is all completed for you. And you know my feelings of when they complete examples for you, how you don't really get a chance to understand it because you don't have the chance to practice it. So we're going to look at this a little bit, and then we are going to do another example here that you won't have in your book. A phone salesperson is paid a minimum weekly salary and commission for each phone sold as shown in the table. Confirm that the relationship is linear and give the constant rate of change and the initial value. So let's look at some of these words first. Minimum weekly salary. So this is going to be the amount of money that the salesperson is paid each week for just showing up to work. The commission, they receive a commission on each phone they sell. So if the company sells a phone for, say, $100, part of that $100 is given to the salesperson as their commission. They might get $5 out of it. So the more they sell, the more phones they sell, they can increase the amount of money they take home because they'll have their weekly salary, plus they'll get commission for each phone they sell. It wants you to confirm, so it wants you to make sure that the relationship is linear. And you do that by finding the rate of change. Now, from the previous slide that we had, the rate of change is also the slope. So although they say find the rate of change, you're actually finding M, the slope. And it asks you to find the initial value. The initial value is also called the y-intercept. So you're finding that B, the y-intercept. So let's take a look at how they solve this. The first thing they did was to use the first set of data along with the second set of data. And they use this to find the rate of change. So when you're confirming, you're actually finding the rate of change. So by doing this confirmation, you're also solving one of the parts they asked you to do. So we're going to do the Y value, the weekly income, 630 minus 480, 630 minus 480, 20 minus 10, 20 minus 10. You have 150 divided by 10, which is 15. So the rate of change for the first two sets of data is 15. Okay, let's use the second set of data. So in our second set of data, we'll go 780 minus 630. You see that? 30 minus 20, 30 minus 20. Again, you get 150 divided by 10, which is 15. So far the rate of change is constant. and it has to be constant. Okay, so here we go for the last set. So remember, you're proving that it's linear by showing that each of these are constant. So we'll take 930 minus 780, 40 minus 30. You see that happening. 150 divided by 10, of course, is 15. So since your rates of change are all constant, you can say that this table is linear. And they asked you to find the rate of change. And you did find the rate of change. That would be 15. So keep in mind that this is also considered the slope. So that's also considered the slope. And $15 represents the amount of money that's paid to the salesperson for each phone sold. So if the salesperson sells 10 phones, they receive $480. Part of this money is going to be the weekly salary. Part of this money is going to be the profit from 10 phones. Then they ask you to find the initial value. That is, what does the salesperson make if they come in each week and they never sell a phone? How much money do they make? This table is the same table that was above. They made this table horizontally rather than vertically for the other table. So you'll see in the other table, whenever they sold 10 phones, the weekly income was $480. When they sold 20 phones, the weekly income was $630. So you'll notice that's the same. As you go from 10 phones to 20 phones, you added 10. But we want to know what happens whenever the salesperson doesn't sell a phone. So rather than adding 10, we're going to subtract 10. And when you do that, x equals 0. So the value of x here is 0. And also look at the weekly income. Prior, they were adding 150 when they went from selling 10 phones to 20 phones. They added $150. But rather than add 150, we subtract 150 and you get $330. So that tells you that if the salesperson sells 0 phones, they'll make $330 that week. And that's called the initial value. Now, please keep in mind that if this salesperson continues to come in to work, sell no phones, and make $330, they probably won't have a job very long. They'll, as one student told me, they'll kick them to the curb. So the idea is that they sell the phones. Okay, so this problem is not in your book. Greg deposits the money he makes from mowing lawns into his savings account, adding it to the money his father gave him to open the account. Confirm the relationship is linear and give the constant rate of change and the initial value. So when you confirm that relationship is linear, you're finding the rate of change. And if they are constant, then it would be linear. So let's first find the rate of change for this set of data. So you'll take 170 minus 110, 10 take away 5, you have 60 divided by 5, and that would be 12. So the first rate of change I found is 12. Let's use the next set of data. 230 minus 170, 15, take away 10. That'll give me 60 minus 5. And just from the last one, it's the same thing as you see here, that'll again be 12. So my second rate of change is also 12. Let's find the third rate of change. 290 minus 230, 20, take away 15. I have 60 divided by 5, and that is also 12. So what you just did was you confirmed that the relationship is linear by finding all three rates of change, and they are the same. You also found the constant rate of change, which in this case will be 12. Okay, so my constant rate of change equals 12. Whoops. Okay. So now we want to find the initial value. So I was increasing by 5 each time. So rather than go up by 5, I'm going to go down by 5. So 5 minus 5 is 0. On my money saved, I went up by 60. So let's go down by 60, and you get $50. So the initial value is $50. But what do these numbers mean? What does the rate of change of 12 mean in this problem? What does the $50 mean in this problem? Now keep in mind that the rate of change came from the lawns mode. So I used the lawns mode to find the rate of change, and I was dividing it by the money saved. So how is this 12 increasing? So how is the lawns mode affecting the 12? And what happens is every lawn he mows, every lawn Greg mows, he makes $12. So by mowing one lawn, he makes $12. 2 lawns, $24. 3 lawns, $36. So as the lawns are increasing, he's making more money. What does the initial value represent? Well, that's with him mowing no lawns at all. So how could he have $50 without mowing any lawns? You have to make sure that you pay attention to what the information is. His father gave him money to open the account. So when Greg walked into the bank to open up his savings account, he opened it up with the $50 his dad gave him. And then for every lawn that he mows, he puts $12 into the account. That's how the money saved is increasing. I'm still on page 102, and these, of course, are the your turn problems. So I want you to pause the recording, try the your turn problem number 1, come on back, check your answer, and then you'll try the your turn problem 2. So pause the video, try the your turn problem number 1, and then check your answer. Okay, so follow along here. On the slope, I took 32 minus 22, 32 minus 22, 4 take away 2, 4 take away 2. So on the y's, I found a 10, and the x's are 2's. So the x's are going up by 2, and the y's are going up by 10. 10 divided by 2 is 5. That's your slope. Remember, your slope and your rate of change are exactly the same. This is the same thing as doing y2 minus y1, x2 minus x1. It's the same thing. You just find how your y's change, how your x's change. For your y-intercept, As I stated before, x's are going up by 2. So if you go down by 2, 2 minus 2, you get 0. X should be 0 to find your y-intercept. As stated before here, the y's are going up by 10. So if you decrease 10, 22 minus 10 would give you 12. Therefore, your intercept is 12. So you try problem number 2 now. Again, pause, try it, check your answer. Okay, so we're back. So what I have here, 15 take away 8, 15 take away 8, 2 take away 1, 2 take away 1. So that's your y2 minus y1, x2 minus x1. 15 take away 8 is 7, 2 take away 1 is 7. 7 divided by 1 is 7. Therefore, your slope or rate of change is 7. Your y values were going up by 7. Your x values are going up by 1. So take 1 away, you get 0. You want x to be 0 to find your intercept. Take 7 away, and you have 1. 8 minus 7 is 1. Therefore, your intercept is 1. Don't be afraid to try these. Okay, if you go to page 103, it says deriving the slope-intercept form of an equation. Now, I don't believe that an 8th grader needs to know how to do that. However, there is something here I want to review, and there's something here new I want to show you. So first of all, the review. If you're given two points and you're asked to find the slope, we use our y2 minus y1 or x2 minus x1. We use our formula for slope. Keep in mind that you label them x1, y1, and then you label this one x2, y2, and now I know where to put them in my formula. So y2 is first. Negative 6 minus, I use negative 6, I'm crossing it off, negative 3 in parentheses to keep my negative and my subtraction away from each other. I cross the negative 3 off. My x2 number is 10. Cross that off. Finally, take away my x1 number, which is 5. Cross that off. So let's see what this equals. I should have an m equals here. So m equals, well, I know that I'm supposed to add the opposite on this one because it has subtracting a negative. And so negative 6 plus 3 is negative 3. 10 take away 5 is 5. I can't reduce that any further, so my slope is negative 3/5. This is the old stuff. We've done this before. You had a big worksheet to do this back in November. So this is old. This is new. You were just introduced to this equation, and I'm asking you to find B. Find the y-intercept. M is slope. So here we are on page 104, the guided practice. We'll be finding the slope and y-intercept of the line on each graph. The easiest one to do is going to be your intercept. And for your intercept, all you do is look along the graph, and as soon as you hit the y-axis, you stop. Now determine what number this is. Looking at your scale, if you go from 0, you go up 1, 2, or you hit a 2, they must be counting by ones then. So this would be 1. So your intercept is 1. For slope, they want you to take these two ordered pairs and they want you to find the slope. That is, they want you to use the y2 minus y1 and the x2 minus x1. But I'm not going to do that. You see, if I have a graph and I can figure out what my rise and my run is, that's much faster. So again, I'm counting by ones on my y-axis. At your x-axis, you're also counting by ones. So let's count up. 1, 2, 3, 4. My rise is 4. My run is 1, 2. My run is 2. I see I have a negative slope. Indicate you have a negative slope. And so negative 4 divided by 2 is negative 2. Therefore, your slope is negative 2. On problem 2, the same idea applies. I'm going to go along my blue line, and there is my intercept. Now from 0, the origin, it goes down 1, 2, 3 blocks. But notice when I went down 1, 2, I didn't hit a 2, I hit a negative 10. So I don't have negative 2 here, I have a negative 10. So I must be counting by 5s. 5, 10. Okay, I'm counting by 5s. That works out. So negative 5, negative 10, negative 15. My intercept is negative 15. You have to be very careful on what the scale is for your axes. They have these two marked so that you can use those as your slope. You can do your y2 minus y1 and your x2 minus x1 if you like. But I am going to do the rise and the run. Now my rise, remember you're counting by 5s on the y. 5, 10, 15. My rise is 15. My run, I'm counting by ones. 1, 2, 3. So my run is 3. My slope is going in a positive direction. 15 divided by 3 is 5. My slope is 5. Okay, on these problems 3 and 4, same type of problems as before. The only difference is there's nothing labeled on any of these lines. That is, there are no points on here for they're telling you to use. So again, the intercept is the easiest. So as I go along my blue line, I hit the y-axis at negative 2. Therefore, my intercept is negative 2. Now, because my intercept is negative 2, I can use that as one of my ordered pairs, one of my spots, in order to find my slope. Let's continue along the line, finding another spot. And here's another spot I can use. I know my marks aren't that nice, but I'm trying to make it so you can see it. I guess you can see that. So let's use our rise and our run. We're going to rise up, and we're going to run right. So if I'm rising up, let's see if I rise up 1, 2, 3. My rise is 3, my run is 2, and my slope is positive. So my rise is 3, my run is 2. That'd be positive 3/2. Now, before we start problem 4, I noticed that these numbers that are marked are not the same as on the x-axis. There on the x-axis, I know that this is 1, 2, 3, 4. But here, if I try 1, 2, 3, 4, that certainly doesn't count. It doesn't work out very well. So if I'm going to go up this spot and then I hit a 6, I mustn't be counting by ones. So if I count by 3, 6, 9, I'm counting by threes on my y-axis. I have to remember that. So following my blue line, I come down to the y-axis and I stop right here. Now that might be the third mark from the 0, but we're not counting by threes here, or by ones here. We're counting by threes. That's 3, 6, 9. So my intercept is 9. We can use that spot for a spot to find our slope. Here's another mark we can use. Look how close they are together. Now I'm going to rise up. Now remember, this may look like one block. However, we are counting by threes whenever we go up. So this is 3, and then to the left is 1. So this is a 3, and this is 1. You have to be very, very sure of what your scale is on these problems. They try to trick you. This line is going in a negative direction. That's going to be a negative 3 over 1. And any number divided by 1 is just itself. So negative 3 divided by 1 is negative 3. Okay, let's find the slope and intercept for these lines for the table. Your intercept is going to be the easiest. If you recall, when we had a table before, I had you figure out how the x's were changing, and then you subtracted that number. So these are changing by 2. And when you subtracted the number, I want you to get a 0 for x. Well, this table already has a 0. There's no reason to say, okay, 2 minus 2 or 0 minus 2. We want x to be 0. And since this x is 0, this one is automatically the y-intercept. It's that easy. Now for your slope. What's the change in the y? To go from 1 to 7, you're going up by 6. What's your change in the x? From 0 to 2, you're going up by 2. So 6 divided by 2, whoops, that wasn't good. 6 divided by 2, why aren't you moving? Something's wrong with that one. So I'm going to say 6 divided by 2 is 3. And so that would be your slope. Who knows what's going on with that stupid thing. All right, let's do problem number 6. Again, your intercept is the easiest because you have a 0 here. Remember, if you were going up by 5s, I'd have you subtract by 5s until you hit a 0. Well, you already have a 0. So y is automatically 140. So your slope is, your y-intercept is automatically 140. All right, let's find our slope. The y's are going down by 20. So you're going down by 20 for your slope. Down by 20. The x's are going up by 5. So positive 5, you're going up. So negative 20 divided by a positive 5. A negative divided by a positive is a negative. 20 divided by 5 is 4. So you can see my slope is negative 4. Okay, how can you determine the slope and the y-intercept of a line from a graph? So if you have your graph, I'll just put a little coordinate plane hickamy-doo here. And I'll put a line for our graph. So remember, the easier one was the y-intercept. And then the y-intercept, all we did was follow along the line until we hit the y-axis, and that number was going to be our y-intercept. So for the y-intercept, all we did was look along the line and see where it intersected. For the slope, keep in mind we used that point. We found another spot, and then we simply did our rise and our run and simplified if needed. Let's see what they have. Find the slope of the line using the coordinates of 2 points found on the graph. So they're talking about using y2 minus y1 and x2 minus x1. We did rise and run, which in my opinion, when you have a graph, is the easiest way to go, unless the numbers are crazy big. Then to find the x coordinate, or find the y coordinate of the point where the line crosses the y-axis. That just means find the spot here where it crosses, and that's your y-intercept. Easy enough.